First derivative test rules. 1. If f prime of x changes from negative to positive at c, then f of c is a relative minimum. 2. If f prime of x changes from positive to negative at c, then f of c is a relative maximum. 3. If f prime of x does not change signs at c, then f of c is not a relative maximum or a relative minimum. Our first function is f of x equals x squared minus 4 to the 2/3. The first thing we'll do is state the domain. In this function, it is negative infinity to infinity. Then we're going to find the first derivative using u substitution. So, if f of x equals u to the 2/3, then we'll derive u. So u equals x squared minus 4, and then u prime equals 2x. Then we'll find the first derivative. So f prime of x equals 2 over 3 u to the 1/3 times u prime. Plug in these numbers, and that will give you 4x over 3 times x squared minus 4 to the 1/3. Now you have to find your critical points using both numerator and denominator. So first, you set the numerator equal to 0, and that will give you x equals 0. Then, you'll set the bottom equal to 0. Divide by 3, and also times the third power to get rid of this, and that gives you 0 equals x squared minus 4. Notice this is a difference of squares, so you can separate it into x plus 2 equals 0 and x minus 2 equals 0. This will give you x equals negative 2 and x equals positive 2. These will be used to break up your domain. So, you have negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. Then you're going to pick a point within each of these intervals to plug into your first derivative. So for this, f prime of negative 3, this one f prime of negative 1, f prime of 1, and f prime of 3. Plug these in, this will end up giving you a negative value. This one a positive, negative, positive. So you'll have a minimum here, positive, negative to positive, maximum, and another minimum. So then you need to plug in your critical points into your original equation to get the y values. So f of negative 2 equals negative 2 squared minus 4 to the 2/3, and that equals 0. F of 2 equals 2 squared minus 4 to the 2/3, that equals 0. And then f of 0 equals 0 minus 4 to the 2/3, which is approximately 2.52. So then your explanation will be the first derivative test yields a relative min at negative 2, 0 and 2, 0 because f prime of x goes from negative to positive. You also have a relative max at 0, 2.52 because f prime of x goes from positive to negative. That is the answer. Our next function is f of x equals cosine squared of 2x. The first step is to state the domain, and because this is a periodic function, it's going to be 0 to 2 pi. Then we're going to find the first derivative but we're going to use u substitution. So it's going to be f of x equals u squared, and u is going to equal cosine of 2x. Now we're going to find the derivative of this, so u prime is going to equal negative 2 sine of 2x. Then we're going to find the derivative of our original function. So it's going to be f prime of x equals 2u times u prime. Plug in for u and u prime, and that's going to be 2 cosine of 2x times negative 2 sine of 2x. Simplify, and we'll set it equal to 0 to find our critical numbers. So that's going to be 0 equals negative 4 cosine of 2x sine of 2x. Divide by negative 4, so 0 equals cosine of 2x sine of 2x. Now what we can do here is break it up into cosine and sine. So we'll have 0 equals cosine of 2x, and then 0 equals sine of 2x. Now what we can do to make this easier is substitute a u in. So we'll have 0 equals cosine of u, and 0 equals sine of u. Now cosine of u will equal 0 when u equals pi over 2 and u equals 3 pi over 2. Plug in for 2x, so you have 2x equals pi over 2, and then 2x equals 3 pi over 2, and then that will equal x equals pi over 4, and x equals 3 pi over 4. Now, divide it. We're going to find where sine of u equals 0. And that's going to be u equals 0, u equals pi, and u equals 2 pi. Plug in for 2x, so you have 2x equals 0, 2x equals pi, and then 2x equals 2 pi. Solve for x equals 0, x equals pi over 2, and x equals pi. However, x equals 0 cannot work because it is not in our stated domain. And also related to our domain, you see we have not reached 2 pi, so we need to figure out the other x values that will work in this given domain. And for cosine of u, it's going to be x equals 5 pi over 4, and another one will be x equals 7 pi over 4. For sine, it's going to be x equals 3 pi over 2. So as you can see, we split up our domains into the intervals that we've stated with the critical points. So from here, we're going to pick a number to plug into f prime. So it's going to be f prime of pi over 6 for this one, f prime of pi over 3, f prime of 2 pi over 3, f prime of 5 pi over 6, f prime of 7 pi over 6, f prime of 4 pi over 3, f prime of 5 pi over 3, and then f prime of 11 pi over 6. So this will give us a negative, positive, negative, positive, negative, positive, negative, and positive. So from here, we can tell if it's a relative min or a relative max. So, by the first derivative test, it yields relative mins at x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if we plug that in, each of these into the original equation, it will be 0. So at 0, because f prime of x goes from negative to positive. It also yields relative maxes at x equals pi over 2, pi, and 3 pi over 2. And that's going to be, if we plug these into the original equation, it's going to equal 1. So these will be at 1 because f prime of x goes from positive to negative. And that's the solution.